All right, in this problem, in this next example, we're going to add and simplify. So in that last problem that we did, we had to combine fractions, and this is very much the same thing. Okay, so again, what is our menu of things? What are the strategies that we use to that we've written down so far to do trig expressions and trig identities? Use Pythagorean identities, we can factor, we can change things to sines and cosines, we can add and subtract fractions or combine fractions. So, problem in this one right here, we have an expression and there's no Pythagorean identities there. There's nothing squared, definitely not going to utilize that right away. There's nothing to factor. Everything's already in terms of sine and cosine, right? This one, and it even says to just go ahead and add this. This is clearly, the next step here is to combine these fractions. So, combine fractions. We have to add these fractions, which means we need a common denominator. We have to go through this process. So as long as you understand the process of a common denominator and adding, then we're going to be all right. So I'm going to write this again down here just because I need a little space. You don't have to write it again. We don't have a common denominator here, right? So we have to multiply the left side by something that the right side has, right? So we think about, well, this right fraction has a sine theta in its denominator. This one does not have a sine theta. It needs a sine theta. So therefore, I'm going to multiply, I'm going to put parentheses around here just to group it. I'm going to multiply this left fraction by sine theta on the bottom, but also on the top. Okay, so we did that. Now looking at our denominators, here and here. Do we have common denominators? No, we do not. Right? So what does the right fraction need that the left has in this with this problem? Well, the right fraction has or needs this 1 plus cosine theta. It needs that whole group. So I'm going to have to multiply the right fraction by 1 plus cosine theta. It's going to have to multiply by that whole group on the bottom, but also on the top. Okay? We have to get common denominators, and this is very similar to having just a literal fraction like, say, 2/3 plus 5/7 or something like that. And if I want common denominators here, you could do something like, oh, let's multiply this by 7. Oh, but then we have to multiply this one by 3 so that they both equal 21. So we're basically doing the same thing here. We're multiplying both fractions by something so that the denominator is the same. Okay, it's just not numbers here. It's this trig expression, which sometimes makes things a little, it looks more complicated, but it's really the same thing. So we have the same denominator now. This is a common denominator. So we're going to multiply the tops out. We're going to combine these tops and see what the result of these numerators are. So let's start with this one. Sine times sine. Sine theta times sine theta. Well, that is sine squared theta. Right? Now, divided by the common denominator that we already have. Notice I'm going to opt to keep the denominator in factored form. I'm just going to leave it like that for now. You'll see why. So the denominator to this is that common one. It's sine theta times 1 plus cosine theta that we already wrote. Plus, now let's look at the second fraction right here. Well, I'm going to multiply that numerator together. Okay, I'm going to distribute this cosine times 1 and cosine times cosine. So the second fraction becomes cosine theta plus cosine squared theta, if we distribute, see how that works, divided by the common denominator that we already have. Common denominator, which is the same one over here, and so I'll just drop it down right here. Same denominator. Okay, so again, you get into this place where we're adding fractions, and when you start the problem seems to kind of get bigger and look more complicated. But a lot of the times with these things, it simplifies down quite nicely. Once we get to the middle of the problem, it then breaks down. It gets easier and easier. So now we have common denominators. So therefore, we can combine these fractions. Now we have a common denominator. And so we're going to add the numerators together. And we're going to keep the denominator. Okay, so this is going to equal a fraction, and it's going to be the same denominator. This one. So my ending result is going to be sine theta times 1 plus cosine theta as my denominator. On the top, right, let me just write what I have. We have sine squared plus cosine plus cosine squared. Okay, so a very similar thing happens now, right? What I'm saying here is sine, you can see sine squared plus cosine squared. Right? Yet another Pythagorean identity is going to pop up there. You know that sine squared plus cosine squared is equal to 1, right? So it doesn't matter that there's a cosine in the middle here, because when I add things, adding is commutative. I can take the cosine theta and just drop it over in a different spot. Let me try it over here. I can take this, put it over here. Doesn't matter the order that I add things. You know, do it like that. Sine squared plus cosine squared. I know that is 1. Right? This is equal to 1. So, take it a step further. Now I have 1 plus cosine theta divided by, my denominator right here. Boom. Sine times 1 plus cosine. And we just did a lot there. It is breaking down. But is there anything more we can do? Right? Think of this, this is a tricky one because there's just a lot of stuff there. Think of the top. Let's group the top. Pop that in parentheses. Let's group it. Okay? Well, we have a 1 plus cosine on the top. We also have a 1 plus cosine on the bottom. Okay? Those two are the same, right? We have similar factors on the top and the bottom. And since they're both in groups, we can cancel these off. 1 plus cosine divided by a 1 plus cosine is still equal to 1. It cancels because it's the same value and you're dividing them. Okay? So this cancels to 1 and 1. So my answer is a fraction that is 1 over sine theta. It's 1 over sine theta because there's still a 1 on the top. So sometimes people will get to this stage and say, oh, these like cancel off. Great. And then they'll just circle this and say, oh, the answer is just sine. No, the answer is 1 over sine because sine was sitting on the bottom of the fraction and we canceled those top and bottom to 1 and 1. So this is my answer, 1 over sine theta, which, man, that looks similar to the last problem we did. That is cosecant theta. Okay, this one, again, similar to the last one, breaks down a ton. You get to cosecant theta, which is like ultra simplification. You take this fraction, again, we went through the fraction, we couldn't do anything but combine the fractions. That was the majority of the work here. Combine the fractions by finding a common denominator. And when we did that, here's our common denominator. Once we combine those, then some interesting stuff happened on top. We had a sine squared plus cosine squared, which is 1, right? That led to this, which led to crossing off some factors and getting to our answer of cosecant theta. All right? So that's a big one. Adding fractions is the same as it's always been. You have to find a common denominator, but when layering it on top of this chapter, this section we're in, there's a couple nuances. We do the same process, but we are using trig identities in the middle of it. So we're kind of using those puzzle pieces to substitute things and to break things down further. So when I said chapter 2, these problems are kind of like puzzles. I really think it's a good analogy. You're using your algebraic skills and these trig identities, and you're trying to break things down.